So the vertical asymptote you find from setting the, I like to call it the bottom. I don't like to refer to like P and Q or something like that in textbooks. You set the bottom equal to 0. And that's a little bit of a lie. There's another scenario here that you'll see maybe next day, but that's thing one. Okay. And then the other thing here, this will definitely help you, is you want to graph as you go. You do not want to wait until the end to graph. It's easy to make mistakes. Uh, I've got the t-shirt that says graph as you go. You should draw a vertical line at x equals 1 or a dashed line there for the vertical asymptote. Okay. Any questions on that?
No, so far.
Horizontal asymptote is always the vertical shift. It's y equals the vertical shift. This one does not have one. When it's in the form of question 3, it's a slightly different explanation. So in this problem, it is y equals 0, but it's still a horizontal asymptote. So it gets a little tricky when you're at the origin there. It's just make some lines there. Now, this is something that I do that I think really could help you. Is I like to add some arrows here. So we know that the graph is going to possibly connect at any of these places. So I like to draw these arrows, and then we're going to connect later on. That would be my recommendation. Okay, x-intercept. So normally you'd set the numerator equal to 0, or you're really setting the whole thing equal to 0, but in this case, it's in the wrong format. So you're really setting y equal to 0, but this one does not have one. This is a none situation. We don't have enough room, but you're setting 0 equals 4, x minus 1 equal to 0. The only way you can get 0 there is when the top is 0. The top is never 0, it's always 4. That's why there is no x-intercept. Is that clear?
Yeah.
Okay. Y-intercept is when x equals 0. So you're putting 0 in for x. So it's y equals 4 over 0 minus 1, which is negative 4. So it depends on the instructor. Usually they want an ordered pair. So 0, negative 4, we're going to graph that point there. Graph as you go. All right. Domain and range. A little bit easier to get those after you graph. So the short of it is that this is the graph. Looks like this. And it looks like this. And it does have to connect. This one doesn't have a lot of stuff going on. So what your teacher could ask you to do is do a test point in each region. Did you guys talk about that at all in class?
I don't think so.
Okay, so the parent function has this form like this. That's another way to do it. But then there's a lot that could affect the parent function. So yeah, lots of challenges. It's a pretty tough unit. Like you felt like the last one was tough, of course this gets a little bit more difficult. Okay. Any questions, thoughts on that before we go to domain and range?
Um, Wait, wouldn't you have to find a point on the other one as well?
You can. Depends how accurate you need to be. That's why I was talking about test points. Like you might put in like 2
Oh yeah, I
in
think
for
she
X.
said just to go like yeah, for I think actually no, it was a different one. But just like uh yeah, pretty sure she wanted you to just like a table where it's like X and Y and just type, put in like the XI for example for that one, you could do like X4 or something like that or 2.
Yeah, it all adds time though. That's the thing. You've got to be very careful here. You just really, really, really slows things down. But yeah, I mean that would be that point there and that point there. Plus, a lot of times they don't work out very nicely. right, so the domain is uh everything, it's broken up by the vertical asymptote. So it's typically like minus infinity to the vertical asymptote. Could be more than one, union vertical asymptote to infinity. That's typically the format here. But you could have more than one vertical asymptote, so you have to, it's not a full-on answer. Same thing with the range, it's minus infinity to the horizontal asymptote, union um, horizontal asymptote to infinity. But again, there's variations on this. So any questions on that? So yours is
Um,
minus infinity to zero, union zero to infinity.
so you would stop at the asymptote and then continue after it.
For some, not all. Like 80% of the time this is true. There's exceptions you will see.
So negative. Okay, got it. Yeah, yeah, I get it now.
Okay. All right. Move on to the next one. Number three.
Yeah, yeah. Let's move on to that
Okay.
one.
So a lot of the same stuff here. You set the vertical asymptote, you set the bottom equal to zero. You get x equals -1. I would graph as you go.
Got it.
Which is, over here, something like that. All right. The horizontal asymptote, there's this when it's in this form where it's one fraction. This is called one fraction. It's considered you look at whether it's top heavy or bottom heavy based on the degree. So these have the same degrees. So do you remember that from class? It becomes the ratio
Yeah,
of the
it
leading
becomes the
coefficients.
yeah the leading
Okay.
coefficient.
But there's three scenarios. There's which we'll get to. So y equals -2. And let's see here, -2. Looks like that. All right. Is that and you should label these. I'm really bad at that, but we should label them. And then, like I said, especially the more complicated ones, you'll find that if you don't put these arrows, you can forget, like you're not sure where things connect. So it's good to have some of these because you will connect some of them in the end. All right, next thing is x-intercepts. So that's setting the numerator equal to 0 when it's a combined fraction. And you get x equals 3/2. As an ordered pair, that's 3/2 comma 0. It's rare when they work out like all nice. You're going to get some fractions in there, 1.50. And then the y-intercept is when x equals 0. You're putting 0 in for x, -2 times 0, +3, 0 plus 1. 3 over 1 is 3, so it's 0 comma 3. All right.
Got it.
All right. So then the thing is you typically cannot cross vertical and horizontal asymptotes. You've got to get to this point, which one are you connect? You'll see here, like the only reasonable way to do it is this one right here.
Yeah,
And then you're supposed to, like you told me, make a table for the other one. Um, I don't really like that, but that's what your teacher wants you to do. So let's go -2 in for x. That's -7, it looks like. You can see I kind of hit it anyway, knowing that.
Got it.
Okay, now so domain and range. Domain is broken up by the vertical asymptote. Range is broken up by the horizontal asymptote. Does that work?
Yeah.
Okay. All right, go ahead and send over what you're gonna work on next. I'm just gonna step away for 30 seconds while I wait for something in the chat and then I'll unmute. All right, I am back. Let me know when something's in the chat there. Boy, big exciting one here. Okay, so I still haven't gotten exception yet. Apologize if you hear the siren. So actually there's a first step here, which is to factor the numerator and the denominator. There's certain things that work better in factored form. So I'll factor which one do you want to factor, the top or the bottom?
Um, gonna do the bottom first.
All right, very good. So go ahead and give me the bottom, please.
X minus 4, X minus 3.
Very good. Now, if a factor cancels, you have a hole. So this one you have a hole at x minus 3 equals 0 because those factors cancel. There's a hole, and the hole is at x equals 3. Now, to get the y coordinate of the hole, you use the reduced form, and you put x back in. So you get 3 plus 4 over 3 minus 4, 7 over -1, which is -7. There's a hole at negative x is 3, y is -7. And you have to do this first. So the holes come first. They come before vertical asymptotes. You do not do vertical asymptotes first. That was the deception from the earlier problems. You actually look for holes first.
Got it.
Okay, so let me snip in the the table there is stuff. Now you typically use the reduced form of this. So we have the whole, according to the whole, 3, -7. Vertical asymptote is when the bottom equals 0, so x equals 4. And then the horizontal asymptote
That'd be
is
1.
1/1 or just 1, yeah. So let's graph a few of these things now that we've got them. So let's graph here. Let's graph the whole, the horizontal asymptote, vertical asymptote. So we got one at 4, I think I said. We have a horizontal asymptote at 1, and then a hole at 3, -7. So I make I really emphasize that there's a hole there. Really overdo it. And then you'll see me adding these arrows in. Okay. Now we go back and find the x-intercept. So you're setting the top equal to 0, x plus 4 equal to 0. That's what's the hard part, is like remembering all of these things. So that's at -4. And then the y-intercept is when x equals 0, 0 plus 4, 0 minus 4, 4 over -4 is -1. So that's right here. And then you connect the dots.
Got it. So after like finding around 2 points, you're able to kind of figure out like what direction generally it's gonna go in.
Once you
Got
start
it.
connecting, if you do need that other point there, um, 5 is a good point. 5 becomes 9.
And yeah, so then to find the point, you would just plug in the x into the
Yeah,
x values to get that. Yeah, got it.
per branch. I haven't heard that before. We're definitely not plotting the 2 points per branch, more because I'm not doing it. You probably are.
No, no, I was just asking that like, so after like you would generally get the direction that it's gonna go in if
Yes,
once you point,
yes.
once you plot a couple points and then you'll know like what direction it's gonna go in, so you can.
Yeah, I mean, you could actually, like, the way your teacher's doing this, you might plot the points first so you know where you are. I mean, that might be easier to do. I don't do that until the end, but that's up to you, because that's a good way to do it.
Got it.
Yeah, I'll be right back with you. Just need a minute or two here. Okay, I am back. You have a new problem for us to look at.
Yeah, let me just put it in the chat. So this is in 7.4 now. The previous one was from 7.3 day two. This is from 7.4 writing equations. I had a question on this problem from the note.
Okay, it looks like it's more of the same though. Like I'm not seeing like we'll do it obviously, but I mean, you're just going backwards, right? Karthik?
Yeah.
Okay, just making sure. Like,
I think the part that I had a question on was
well, so let's see if you can tell me some of the
two
things here. Tell me,
functions.
can you
Yeah.
tell me the vertical asymptote equation?
X equals 4,
Yes. Horizontal.
y equals -2.
Okay. How about the X? Give me the X intercept. That's the easier one.
uh 2 comma 0.
Okay. The Y intercept, I guess it's 0, -1. It'd be nice to have some more grid lines in there. How about the hole? What's the coordinates of the hole?
Coordinates of the whole would be -1, and then if that's negative, then probably -1. Yeah.
All right. Now the domain, we have not talked about this. The domain is broken up by both holes and vertical asymptotes. So this one is -infinity to -1. That's the hole. -1 to 4. That's the vertical asymptote. 4 to infinity
Got it. So it's kind of split up between the asymptotes and holes,
and the
kind of.
holes. Yeah. The range is similarly broken up by that. So it's really domain and range. So it goes from -infinity to -2, union -2 to -1. That's the y value of the hole. -1 to infinity.
Got it.
All right. So is that okay?
Yeah.
All right. Factored form. So this is the hardest part. So it's the x intercept x -2 over um x -4. But then,
Yeah, I think the hardest part I found was forming the equation for
yeah,
factored form, because for
but
standard form it's just multiplying it out. But
yeah, right. So, but then this doesn't satisfy everything, but it satisfies vertical asymptote, x-intercept. It does not satisfy uh y-intercept though, which is bad. Did I miss something here? So, what am I missing? Okay, so this is there's really a -2 here in front. That gets you the horizontal asymptote because you can think of it as -2 over 1. Do you agree with that?
yeah,
And then does that give you the y-intercept? You kind of have to go back and make sure everything is checked. Well, it gives you -2 over -4, but then when you multiply by the -2, that gives you 4 over -4, which gives you the -1.
got it.
So now we're doing better, but we still don't have the whole thing. We need the factors that cancel because they're the whole at x plus 1, x plus 1. because when x plus 1 equals 0, that's the negative 1 for the whole. But then we have to make sure that when you put negative 1 into this part, that it gives you negative 1. Negative 1 minus 4. So I don't know if this is going to work. 6 over, yeah, so I don't think that was actually the coordinates of the whole. It's really close, but this ends up being negative 6 over 5. You might ask your instructor about that. Like if you're supposed to do it
Um,
from the graph or wait until you
since
get the
this is the
factored form.
note, let me go check. Yeah, what is mm, no, he said that the whole is -1 comma -1. Find the factored form is y equals -2 times x minus 2 times x plus 1 over x minus 4 times x plus 1.
Okay. Well, you're welcome to check this, but it's it's not negative 1. It's negative 6 over 5. You can tell your teacher they're incorrect. They probably won't like that very much, but that is the case.
Um, she did, however, say today in that's that like if it was to be like a fraction for the whole, like if it was -1 comma like a thing like a decimal or something like that, to just make it an integer, so that might have to do something with it because we made it -1 comma -1
Okay. I mean, that's
rounded to
kind of
like the
a
nearest integer.
interesting take on things.
I think that's what she
You're
said
not
in class today during the
in
note.
I mean that's like an engineer. Engineers would do that. They would actually say like, yeah, it's about this, so yeah, it's good enough. But that's not how you do it in kind of pure math. But nevertheless, your standard form you have to FOIL. So you have x squared minus x minus 2, x squared minus 3x minus 4. You multiply the top by -2 over x squared minus 3x minus 4. So you're foiling.
Basically, you're multiplying the x minus 2 times x plus 1 on the numerator and x minus 4 times x plus 1 on the denominator.
Yep.
And then
Yep.
multiplying it by, well, the bottom would already be it, but the top we'd have to multiply it by -2 to get the final standard
Yes.
form.
Yes.
So,
You don't get as many questions on this type of test, or your teacher might give you more of those multiple choice questions where they ask for like one piece of information out of the 6 here or 8. They'll trim it down to make it more manageable.
I do believe that the next test we have coming up is the chapter test. That's the
Right.
only test we have coming up other than the final that we have. Um, but I believe that's like next Tuesday's our test on chapter 7. Uh, the yeah. Usually like the last chapter test I think was it had some multiple choice. I think like we might have one here that like the entire problem like this. Uh, so, so- I wanted to try these two. On the homework, and she let us to start a class, but I got stuck with one of them. Let me pull it up. These two last ones on the one.
Okay, so I'm sorry. So you just sent over some new problems here, kind of the same thing. Oh no, was eight the next one? Sorry, do you want us to go through eight?
Um, we can go through seven first. That's the
Oh,
longest.
okay. So I guess we can. I'm sorry. It looked so much like the previous one. I was like, oh, all right. Here's seven. Let's look here. So, all right. So nice graph here of it. All right. For a vertical asymptote, what is the equation of the vertical asymptote? X equals what?
X equals 3.
Yes, X equals 3. And then horizontal asymptote Y equals,
-3.
yeah. So you could try to build the equation here, but I think you need a bit more. I think you need the X and the Y intercepts to do that. Can you give me either of those, please?
Would that be the x-intercept at 1 comma 0
Okay.
and the y-intercept? I think it's negative
Looks like 0,
0 comma
-1.
-1. It
All
looks
right.
like
And that's
that.
where you could, because the whole kind of hard. All we know is that the whole is at X equals -1. That's where you might start building the equation. So give me the top part if the X intercept is 1, 0. What goes up here?
X-intercept is 1, 0. It would be
So remember, you set the top equal to 0, get the X intercept.
so it would be x -1.
Very good. And then the vertical asymptote is setting the bottom equal to 0.
That's -3.
Okay. Very good. Now the next thing is the horizontal asymptote. I would, so just whatever this fraction is, you put that in front there, and then you hope that the y-intercept work with it. Like when you put 0 in for x, do you get -1 for the intercept?
Yeah, you would get -1.
You do. Very good. And then you would add in here the whole, which is x plus 1, which then allows you to figure out the y value of the whole by putting -1 into the reduced form. This is 6 over -4, which gives -3 over 2. And that allows you to figure out the domain and the range
Yeah,
and the factored form. So why don't you try the domain?
so the domain would be -infinity to -1, and then -1 to 3, and union and then 3 to positive infinity.
Good. And see if you can do the range also, please.
The range would be from -infinity, wait, -infinity to -3, wait, -3 to negative, yeah, -3 halves, so then -3 halves to positive infinity.
Very good. Okay. Factored form, we got standard form. You have to multiply out. Top is difference of squares. Bottom is boiling. All right, so why don't on number 8 here, why don't you try to come up with the equation? Take a few minutes to work on that. That is really the hardest thing, is to come up with the equation. Um, fill in what you need, but you need to do the equation, you need the x-intercept, the y-intercept, the vertical asymptote, and the horizontal asymptote.
Found it. Um, I got the equation y equals x minus 5 over x plus 1.
Like this.
Yeah.
That's your final answer. Okay. That works for the vertical asymptote, -1. Horizontal asymptote is y equals 1. It works for that. The x-intercept is 5, 0. 5, 0. Works for that. And the y-intercept is 0, -5. Works for that. Very good. So now what would you add in for the whole? What would go here?
It -3, comma 4. So it would be x plus 3 and x plus 3.
Very good. So now when you put at x equals -3, when you put -3 into the non-reduced part, that'll give you the y value of the whole.
A over So 4.
It is 4, yeah. And we actually see that in the graph, but it's just confirmed there. Okay. So see if you can come up with the domain and range.
All right, for the domain, I got negative infinity to -3, union -3 to -1, union -1 to infinity.
All right, and the range,
The
whenever you're
range
ready.
would be negative infinity to 1 event union 1 to 4 union 4 to positive infinity.
Okay, good job.
Right, and then this in standard form would just be
Foil that if you'd like. All right, anything else you want us to look at today, Karthik?
I think that's it. Yeah, I don't think I have any more questions.
All right, well, thank